Hello everyone and welcome back to episode 31. We're back after the 2 weeks. This is the first one after we've done a bit of an extended break. Bit of a weird one. Sam's got a beer.
Oh, yeah, shit, I've got
Sam
a beer.
has got a beer
Wow.
for the first episode in a while.
Normally I have a Diet Coke, don't I?
You do? Normally have a Diet
Yeah,
Coke?
I've give up on me diet. Just beer now.
I don't know why you pretended to be on in the first place. But as you say, we're back with another guest. But our guest, he has not been on Love Island. He did not co-found Facebook. He did not play the drums with Adam and the Ants or produce records Tears for Fears. He didn't win Mastermind or the Brain of Britain, but he is a professor from the University of Liverpool. So welcome, Professor Chris Hughes.
Hey!
Thank you.
We saw that on your profile. We're like, we've got to mention it. So how did that come about? Where did you figure out there was many Chris Hughes?
Oh, there's hundreds of us.
There's a lot.
In the old days when we used to get the phone book delivered, the Liverpool phone book had pages and pages of Hugheses. C. Hughes was at least 3 or 4 pages. There's even a column of C.W. Hughes. So,
Just it is quite a popular second name, isn't it?
yeah. Especially around here.
Yeah.
I wonder why that is. Do you want to say who we need for that?
Who?
Oh, what, the historian?
Chris Kavanagh.
Chris Kavanagh. So we had a
See,
historian.
there you are. Another Chris.
Oh yeah, Chris. We've not really helped our own thing there. But no, he's a historian, but he does a lot around Chester. Some of the stuff he just rattles off. You're like, how do you know that?
If you mention a second name, he dives into the history of that second name.
Oh, and he just knew it.
He just knows about any names. But
yeah, so as we introduce you, you're a professor at University of Liverpool, researcher. However, how would you introduce yourself if someone were to ask?
That's a tricky one. So I'm kind of an oceanographer.
yeah.
Mm-hmm.
But when I say I'm an oceanographer, people always ask me about dolphins and stuff like that.
That's what we had planned to ask you. What are you talking about?
Right, I'm just gonna delete that.
Because I come at oceanography from a very sort of planety, spacey angle.
Yeah.
So the best term for me is a geodetic oceanographer, but no one has a clue what that means.
Which? Repeat that.
Geodetic.
Geodetic. Okay.
So geodesy is the study of the shape of the planet Earth and its gravity field.
Right.
And really it's using those kinds of ideas to study the ocean is what I do.
Brilliant.
So the shape of the Earth includes the shape of the surface of the ocean, the sea surface.
Okay.
By definition.
Yeah. And a lot of that is gravity. So
Wow.
sea level is level.
Yeah.
I love it. This is going to be a great episode. But before we get into the actual interesting bits, we have a little silly portion at the start. We like to break the ice with the guests we have on.
Yeah.
Very highbrow questions. That is said with a wink. They're not really.
Took hours to create.
Took hours to create this. So the first one, Chris, is what is your favourite sandwich?
Oh, that's a tough one.
It stumps
We
everyone.
need to get to know
It
you more,
stumps
Chris.
everyone.
You've mentioned geodesy, and we're going to talk about it, but we can't move on until we know more about
I'm going to
you.
go with peanut butter and Marmite.
A Marmite.
Yeah.
That's the first Marmite shout we've had.
Peanut butter.
Do you love it or do you hate it?
I love them both, but I've never
I
had them
don't.
together. I love peanut butter. I love Marmite, but I've never had them together. What's that like? Like the saltiness of the Marmite with the.
Yeah. It really adds a sort of depth to the peanut butter.
Yeah, I'm gonna have to get on
At
that.
one point, they started selling peanut butter and Marmite mixed.
They didn't they, with the swirl? I remember seeing stuff like that.
This is just a proper bit of British law I'm not accustomed with.
I've bought. What's the brand that makes Marmite?
Is it just Marmite?
Is it Marmite the brand?
Well, it's Lever Brothers ultimately, I think.
Oh, right.
Well, I remember seeing my mum bought them a jar of peanut butter with Marmite like flavouring in it.
Yeah.
As you were saying, yeah, I've had that.
What-
But I've never had it on a sandwich. I've never tried it.
I think that's the most out there one we've had. However,
On toast or bread?
Toast is better.
Yeah.
that's what I mean. Like, I can't judge it because I really don't like Marmite. But
No.
I've tried it. I've tried to give it a go. It's just not for me.
Yeah.
Love it or hate it.
You
There's
do love it or hate
What's
it?
the Australian version? Vegemite?
Yeah.
They don't like that either.
Apparently you can get Vegemite chocolate or something, can't you? Have you seen that? You onto that?
You can get Marmite chocolates as well.
Oh no, not for me.
I've had peanut butter and jam, never peanut butter and Marmite. I'm going to have to get
You have
on
to give
it.
it a go, and you give us a review next time you come on. You have to do it before the next episode.
I'm going to review your sandwich, Chris, on the next episode.
This will be
Before we get into the next guest, I'm going to go, wait a minute, I need to give a review on the Marmite
The
and
first
peanut butter
actual
situation.
sandwich review.
Yeah.
So I'm going to have to come back and listen to the next one as well.
Yeah.
See, that's
see what we
that's the
give you,
game.
yeah.
That's the game. So, question 2. It's the standard question everyone asks. Dead or alive, 3 people. Who would you ask around for a nice little dinner party?
Can be anyone. Doesn't have to be,
Doesn't have to be
famous
famous.
people.
Yeah,
Could be
well,
someone you know.
I'm going to have Richard Feynman there.
Okay.
Edmund Halley.
Who's that?
Halley's Comet.
Oh, is that that's named after?
He named that. Did he discover that comet?
He predicted it was going to come back.
Okay.
And
So
you got to have someone to lighten the mood a bit.
I'm going to say, you got two scientists there. Who else are you picking?
Robin Williams.
Robin.
Oh, what a show.
Oh, what a, yeah.
That'd be a great dinner party.
Yeah, the late Robin Williams. Wow.
Because that's what I mean, you'd have some great discussion then, Robin Williams, just cracking jokes in the back. It'd be a great one, that.
Have you seen Robin Williams' piece on golf?
No, I've not seen that.
And he's like, why they try and make it hard.
Yeah, he went, who invented golf? He went, the Scottish invented golf. He went, they put a tiny ball down. And they're like, oh, what are you going to do with that? Are you going to create like a net over there? He went, no, we're going to have a hole thousands of yards away and we're going to hit it. Oh, that's all right. And what else? And we're going to put sand and hills in the way. It's going to be impossible to play.
If you have to something to watch tonight, watch that sketch. It's hilarious.
Yeah,
it goes on for a bit. It's so funny.
But that's a good shout. I like that.
It is. And the final one is, what is the worst job you've ever had?
Ooh.
Don't say the current one. I can imagine that'll land you in some trouble.
I was a sales assistant in Dixon's once.
Oh, okay.
Selling electronics, cameras and stuff.
Oh, yeah.
Over
in the
Christmas.
store? Or,
yeah, in the store.
Was that when you were younger?
Yeah.
Yeah.
Horrendous.
And that was, it was all just about shoving stuff through the door. Get
people
anyone
to buy
take
something.
anything away. It doesn't matter if it's broken. It doesn't matter what. Just they'll come back after Christmas. It doesn't matter.
Yeah.
Oh, so basically just boost these numbers up before Christmas, and
Yeah.
it doesn't matter what that number consists of.
Yeah.
Wow. Yeah.
Dixon's, are they still going? Or
I think they got absorbed in Curry's and
okay.
PC World and all that.
Say,
in the
as
end.
the few is it Wilco's an OG, another OG shop to go?
that's recently that
Yeah,
done,
that's
wasn't
what I
it?
mean.
Remember Maplin?
Maplin. You're thinking of Matalan.
Matalan, yeah,
you've
I've
combined two shops there.
Yeah.
I used to go in Maplin and just walk around, look at the stuff.
Yeah, to just be all mad electronics.
I think that's where my love of electronics came. I used to walk around and look at the stuff, and then once I had an understanding of like the prices of things, I'd walk around the shop and go, "How are you charging that?" And then that used to be something. I'd go in the shop and go, "Why are you?" And just see what they were overcharging.
You know what I
for,
remember
'cause
about?
I'm sad.
This is going off topic about Maplin and like places like electronic shops. There'd always be one of those disco balls spinning,
Always at the back,
Yeah.
in the back corner.
and you'd be. When I was a kid, I'd go in and I'd go right to it, and I'd be like, "That's sick."
I want a
And
disco
a lava
ball.
lamp would be in there as well, and one of those electricity things that like.
Oh, you put your hand on.
Yeah, they'd always be in there, and you'd be like, "This is the
A
best."
disco
shop
ball and a
ever.
lava lamp is something we all wanted as a kid, but never bought when we got older.
Yeah,
Because
my
we were
mum
like,
always said no, and then
Yeah.
when I got older, I never got one anyway.
yeah, because then
Never
you're like,
just-
why would you buy one?
Yeah,
With your own money.
maybe there's a reason why she said no.
Yeah.
It was Tandy when I was growing up. And
Which?
Tandy.
What's that?
That was the equivalent of Maplin. It was,
Oh,
same
is it
thing.
okay?
Yeah.
Just walk
and-
around, see all the stuff in.
And they'd have all sorts of weird electronic stuff. And then one day there was this big box with a screen on top of it, and everyone was looking at it and said, "What the hell's that?" It was a computer.
Ah, the
first
first
computer.
computer.
What was the first main computer brand? What was it? Was it Lord Sugar's one?
Oh, the Amstrad ones.
Yeah,
Amstrad.
were they the first ones, or was the ones before that?
Well, there's
or-
a bunch of them at
Oh,
the same
yeah,
time. So
IBM.
I was a ZX Spectrum guy. So that came from the ZX80 and the ZX81,
Yeah.
and then the Spectrum, and then there was the BBC and the Amstrads.
What could you even do on a first computer? Just like log in.
was it just
That
word
was it.
processing? Was that like the main aim?
No, it was programming.
Obviously, yeah.
They didn't do anything.
And it'd be
Yeah,
quite,
literally.
it'd have been quite machine level as well, I'd imagine, surely.
Well, it came the Spectrum came preloaded with BASIC,
Oh, right, yeah.
and in fact the keys have the commands on them. So you don't type 4, you press the 4 key.
I need that in my life. Like right now, the amount of times I write a for loop, I probably shouldn't. I should probably learn to be more efficient. But the amount of times I write a for loop, I need that macro.
You need a 4 macro.
I need a 4 button just to do it for me. Hey. So, moving on from
random questions.
questions to break the ice to why we've actually asked you here in the first place. So we've done some reading, as you say, about your speciality. So it's geodesy and sea level sciences. So what we'd like from you, if you wouldn't mind, is to give ourselves and the listeners and the watchers kind of a breakdown into kind of what each of those two research areas are, what are the differences, similarities, that type of thing.
Okay, so it all starts for me from trying to understand ocean circulation, how the ocean flows, and what makes it move and do what it does. And that's all to do with forces pushing it around. And the biggest force is the pressure gradient force, which is sea levels high in one place and low in another place. It pushes the water from high to low. So a lot of what's going on in the ocean, you can actually see imprinted in the shape of the ocean surface. If there's high sea level somewhere and low sea level somewhere else, it tells you where the currents are flowing. Now, it's not doing it in the obvious way. You'd think the water goes from high to low.
Yeah.
No, right angles to that. The water goes along the slope. So if you're in the northern hemisphere, if you've got a current flowing forwards, then sea level on the right of it is high and sea level on the left of it is low.
Hold on, that's confusing.
How's that happen?
It's because the Earth's rotating. So anything that happens, we're so used to living on these short time scales where stuff happens in a few seconds or a few minutes. If I threw a ball to you, you'd expect it to go in pretty much a nice little arc, a straight line. But if we did it all in slow motion and I threw the ball across, and gravity was weak enough so that it took a long time to get there, and say it took 3 days to reach you, it would never reach
That'd be one bad
it would
game
go
or
round in
something.
circles.
It would go round in circles.
It would go round in circles instead
because
of
the Earth's rotation.
Because we're on a planet that's going round in circles, and anything that takes longer than a day or so, most of what's happening to it is it's going round in circles. When I throw the ball to you, it's going around in a slightly different circle, and it just makes it wobble around a little bit.
That's so sick.
So, sea level. Explain that again. Sea level is an angle to.
So when the current's flowing, it's flowing with high sea level on its right, low sea level on its left. So the Gulf Stream, for example, the biggest current comes out from the Gulf of Mexico around the tip of Florida and flows to the northeast. So sea level south of the Gulf Stream is almost a metre higher than sea level north of the Gulf Stream.
That's insane. So it's like a metre, like obviously goes down on a grate. That's crazy.
And there's an easy way to think of this. Stir your tea. When you stir your tea, and if it's steadily spinning all the time, you get high tea level on the outside, low tea level in the middle.
It makes sense.
It's just the thought that the sea can be in two different levels, because obviously that goes against the.
It's abstract, isn't it? From someone like our perspective, it's very abstract.
When someone says, "Well, sea level's rising," which one? Do you know what I mean? That's now the question, because now I always thought sea level was just the sea
uniform.
Level. Yeah. That's crazy. So when was that first discovered then? That was. Well,
it was probably first worked out around 1900, but in terms of measurements, it's only very recently we've been able to measure it that accurately to see. So we now have satellites that can measure where the sea surface is to an accuracy of centimetre or so.
Is that to do with light reflecting back to the satellite or something? Or
they do radar.
Radar
pulse, and they time how long it takes to get there and back.
That's amazing. So I suppose the question is then, from two people who aren't involved in this kind of research, is what is the overall aim of this type of research? Like, why should other people, not to put it in a different way, but like, why should people care? Why should people get involved? Like, what are the main outputs of this type of research?
There are two ways round. One is trying to understand how the ocean works in order to say what sea level is going to do in the future, and that really does matter to people.
Of course, When
sea level rises, people get flooded.
And all the
salinity gets soaked into the farmland, so crops can't grow because they got the.
So the idea of one of them was to understand how the sea level got to where it is at the minute, and then try and use that to extrapolate forwards and try and figure out what it's going to do next.
Yes, that's right.
Right.
So there's that way round, and then the other way round is using sea level as a way of measuring what the ocean's doing, in order to understand the ocean's role in the climate system, because the ocean carries a lot of heat around. So heat basically comes in at the equator, when the sun's hot. Radiates out at the poles where there's much less sun coming in, and it gets transported between the two. And a lot of that's the atmosphere. It's carrying warm air from the equator away to the poles, but a significant chunk is the ocean. And the ocean doesn't do it in such a straightforward way. It doesn't take it from the equator to the pole. It sort of does in the Pacific, but in the Atlantic, the ocean is the weirdest part of the climate system. It carries heat from south to north. So in the northern hemisphere, that's normal. That's from equator to pole.
Yeah.
But the southern
yeah.
half of the Atlantic, the heat is actually going from the cold regions towards the warm.
How does that make any sense?
It's called the overturning circulation, or you might have heard of it as the Great Ocean Conveyor Belt, or the meridional overturning circulation.
So heat's moving from the bottom of the Atlantic, or the south of the Atlantic, sorry.
Towards the equator.
From near Antarctica,
Yeah.
the heat travels northwards all the way through the Atlantic to the far north of the Atlantic.
So how does that
does
occur? I think we're about to ask the same
Go on.
question. How does that occur then?
Well, it's all to do with where the water sinks.
Right, okay.
So the ocean is light water sitting on top of dense water. It's quite stably stratified. So light water floats, dense water sinks.
Yeah.
But then if you're far enough north, you've got lots of weather going on, lots of cold air. It can cool the water. Colder water gets denser, and it'll sink to the bottom.
Mm-hmm.
Now, if water's sinking to the bottom, it'll then spread throughout the rest of the world. And somewhere it's got to come back up again. Otherwise, it'll just all fill up.
Ah, okay.
So you get this big circulation where water sinks in a few places, spreads around the world,
And then comes
And then
back
comes
up.
and it
back.
comes up all sorts of different places in complicated ways, with mixing and wind-driven upwelling, and the flow in the circumpolar current around Antarctica pulls a lot of it up to the surface. But the point is that it sinks only in a few spots, and one of those spots is the northern North Atlantic and the Arctic region.
And then that pushes it up towards the equator instead of the other way around.
So that water's sinking, you're losing your warm water from the top, it's going down, so you have to pull water in from somewhere else, and that's coming all the way from the rest of the world. So it's coming northwards through the whole of the Atlantic, and that's the warm water at the top is going northwards, and it's cooling and sinking, and then going back as cold water,
And then reheating.
and then reheating somewhere around the world eventually, and to close the whole loop.
So how does it heat though? How is it originally hot near the Antarctic?
So
Why would it be hot down there? You know what I mean? This
you've
is
basically got warm water on top of cold water.
yeah.
Right.
That's not all there is to it. It's also fresh water on top of salty water, or
Okay.
vice versa.
Yeah.
So fresh water floats on salty water,
Yeah.
warm water floats on cold water. We've got both going on at the same time. So
Okay.
sometimes you can have warm on top of cold. Sometimes you can have cold on top of warm, if it's cold fresh on top of warm salty.
So if the fresh overrides the heat.
So like the hot water's underneath kind of all the ice and whatever.
Yeah, so
That's so mad.
there are actually patches around Antarctica where you do find that, where that you've got cold above warm, but it's very fresh cold water on the top. So there's a lot of stuff going on. But the big issue really is you've got dense water, how does it become less dense? Mm-hmm. Some of that is when you've got strong enough currents, instead of being stratified completely flat, so that you've got less dense, more dense, more dense as you go down, those surfaces can gradually tilt. It's the same thing as the sea level tilt. So when the current is flowing strongly, it tilts those internal surfaces as well, much more than it tilts the sea level.
Right.
I'm sorry, this might sound like a really basic question. What does the word density mean in relation to water? How can water be more dense?
So it doesn't compress very much. Water is... So density is the amount of mass in a...
So that's just
particular-
really confusing for me.
No,
I thought
if it's
water
to do
was
with-
like
it's to do with the
all
pressure, isn't it,
created
pushing
equal.
the-
So there's three things
Yeah,
that affect
okay.
sea level, not sea level, ocean water density.
Yeah.
Pressure, if you squeeze it, it will compress.
Okay.
Only a little bit. But actually, if you're in 5 kilometres of water, there's a lot of squeeze going on. There's
Yeah.
huge pressures down there. So in some ways that's the biggest, but doesn't matter very much because it's the same for every bit of water at the same depth almost.
Yeah.
Okay.
What matters is the difference in density from one place to another at the same depth. that's kind of like the difference in sea level. That's what's giving you a slope that's making things move. So those differences come from changes in temperature or salinity. So if you heat water up, it expands.
Does it?
So it
I
gets
wasn't
less
aware
dense.
of that.
That's just normal.
I wasn't aware of that.
If you heat something up, like what gas, like water vapor and water, if you heat it up, it'll expand.
Oh shit!
more
Yeah.
further apart.
Sorry, this is really
Come on,
abstract.
Sam.
This is really abstract for a mathematician. I don't deal with application. I'm just very like, okay.
Oh, so so warmer water is less dense than cold water.
Yeah.
Essentially.
Okay.
Yeah.
And with salt, that's an intriguing one. If you take a bucket of water and pour salt in, then the level of the water will go up because you put some more stuff in, but nowhere near as much as you think, because the salt dissociates. It's sodium and chloride ions. They separate out, and those are tiny little things, and they can almost sneak in between the water molecules. So the salt itself is a crystal with them sort of separated out in a grid. When it goes into the water, it dissolves and effectively becomes much, much smaller.
That's true. Have you poured salt? You think the amount of salt
yeah.
you've got, it would woof.
I've never
But
considered
it does rise, but it's not like But if you put a ball in, it would rise a lot because the ball doesn't.
That's insane. Yeah, so more salt. The more salty the sea is, obviously the denser it is as well.
Yeah, so it's almost as if you're adding mass without adding much volume. You're just sneaking some extra.
That's crazy.
That's weird.
So then, can the density in different places at the same level be caused by different factors, essentially?
Yeah. So some places the salinity matters more. Some places the temperature matters more. Usually, salinity becomes more important as you get towards the poles.
Okay.
Because there's less heat.
Well, mainly because the temperature becomes less important. Ice floats.
Yeah.
And actually, water that's very cold, if it's fresh, floats.
Wow.
That's insane.
I'm going to be lazy tonight testing all these things.
But yeah, like
I'm going to have salt. I'm going to have like freezing water and warm water.
Well, because I suppose that makes lots of sense as well, because obviously the colder it is just before it freezes. If it's fresh, it's going to have less salt in it, so less dense and also less temperature. So yeah, it makes loads of sense.
Yeah. So one of the things that means the poles are the place where the salinity matters more is the fact that if you heat water up when it's cold, it doesn't expand much at all.
Okay.
In fact, if you're in really fresh water, the temperature of maximum density is 4 degrees. So if water gets colder than 4 degrees, it starts expanding again.
Oh wow,
That's insane.
Now in the sea, it doesn't do that.
Yeah.
The salt stops it from doing that.
okay.
But it still has the same kind of thing, where as you get closer and closer to freezing temperature, the expansion gets smaller and smaller.
So it's it's not this kind of linear
Yeah.
kind of relationship. It's more like a.
So if you've got warm water, you heat it up, it expands a lot.
Yeah.
If you've got cold water, you heat it up, it only expands a tiny amount.
Wow.
That's just confusing to me.
That's just crazy. But I suppose the question I've got then, so what happens then or does this ever happen, where there'll be at the same level 2 sections of water, but the densities are caused by different things? Will they ever meet?
Yes.
What are the outcomes of that?
Oh, all sorts of fun things. So a really good one is the Mediterranean water. So the Mediterranean is a place where the Atlantic water flows into the Mediterranean at the top.
Yeah.
The Med is really deep. I mean, it gets down to 4,000 or 5,000 meters in places. But the connection to the Atlantic is only less than 300 meters deep. So you get these surface waters flowing in, and they're salty. But it's hot over the Mediterranean, and it doesn't rain a lot.
Yeah.
And there aren't that many rivers flowing into it. I mean, there are some, they're quite significant ones, but it turns out the evaporation is much higher than the precipitation in the rivers. So the water in the Mediterranean is continually losing fresh water to evaporation. But of course the salt stays behind. So it gets more and more saline.
Over time?
Well, it doesn't, because that flows out again. So that the water gets really salty, and this warm, salty water sinks. So the deep Med is full of very warm, very salty water.
Okay.
And that tips over the lip between the Med and the Atlantic, and that's denser than the water around it.
Yeah.
It sinks and mixes and stirs until it reaches the right density to match the water around it.
Yeah.
And then it spreads, and you can see this blob of Mediterranean water across the whole of the North Atlantic. It spreads all the way across. And it's clearly different because it's the same density as the water around it, but it's warmer and saltier.
That's crazy.
You know?
It's so mad, isn't it? Like, as you say, you'd never know these things unless like you listen to someone talk, like, would just happen
Yeah, man.
all the time.
So, yeah, well, that's just... I'm trying to get my head around, like... I'm still at the level of, like, how there's levels of water. I just knew nothing about the ocean. I'm like, what? There's well, water's not created equal.
Well, I mean,
hell?
that's what I mean. Like, I've never thought about it, but then when you think about it, I mean, like...
It makes sense once you
Yeah,
get
yeah.
into it, yeah.
It's
But
crazy,
it's...
innit?
Because you've never thought about it before in any meaningful way. You know what I mean?
That's the kicker, innit? Yeah.
That, it's like, it's just all new to me.
Do you find that quite a lot then when you speak to people kind of about this topic? Then
Oh,
it's
absolutely. And it was the same for me when I first found all this stuff
Yeah.
out there.
So-
I was doing my PhD was in ocean dynamics,
So
and there was a picture on the wall of sea level, and I looked at that picture and thought, what on earth's going on there? I'm supposed to be doing ocean dynamics and I don't get this.
So,
That's right where I'm at now, Chris.
So how did you get involved then in kind of ocean studies? Was this more of like undergrad, masters, or was it simply at the PhD where you're like, yeah, this is like my topic?
Well, I grew up in the sort of 70s, early 80s,
Yeah.
when there were lots of space probes going off. NASA was sending, the Voyager missions,
Yeah, of
course,
Viking
yeah.
to Mars and things like that. So every few years there'd be some amazing new pictures coming out telling us about how the solar system works, and it was just some tiny little space probe whizzing past a planet briefly, and then suddenly they'd tell us they knew all these things about a whole planet just from flying past it briefly. And I was just mind boggled by that, the idea that just by having a quick glance at a whole planet you could understand something about.
Yeah.
You look at the Earth and you think, what's going on in my sink is impossible to understand when I'm doing the
Never
washing
mind
up.
the little probe flying
Yeah.
past. I know what you mean, yeah.
So is that what really sparked the interest?
So I was always interested in this thing about how do you understand a whole planet,
Yeah.
and so I did a physics degree,
Okay.
but I was always keen on that side of it, the astrophysics, the planetary physics.
Yeah.
And that was my third year option, was physics of the atmosphere, oceans and solid earth. And that just got me totally hooked, because
That module, you were thinking that is what I want to do, yeah.
there was one particular result about how the ocean works, which is you blow the wind on the surface of the ocean and it stirs up the top layer. It makes all sorts of turbulence and complicated, hideous, messy stuff.
Yeah.
But again, similar to this thing about the slope relating to the currents, there's a relationship between the wind stress and the bit of the current that comes from that. If you know the stress, that's the force
Yeah.
per unit area on the surface, you then know exactly how much water, the total volume per second, is travelling, again, at right angles to the force. Doesn't matter what the turbulence is doing, doesn't matter
how complicated the dynamic of this interaction is.
it doesn't matter how deep that layer is, how much the turbulence spreads downwards, as long as it doesn't reach the bottom, as long as it's trapped in some layer up near the surface. The details don't matter at all, because rotation of the Earth is so important to the dynamics. You can say something about the whole system without knowing about the details, and that's what gets my juices flowing.
Yeah,
is that,
like-
what can you throw away and still get it right?
Yeah, like what is the bare minimum model that still explains essentially everything we need to know?
Yeah.
I love that type of like
Minimalism.
analysis.
Yeah,
just
yeah.
that like you can get caught up in the noise of it all, but what you actually need to know is actually quite incredibly simple, to some extent.
That's like a metaphor for life, I think.
I've-
Get rid of the noise.
Surely some philosopher said that somewhere. I can't have just made
I
that
suppose
up.
every problem, though, you do. There's a lot of noise around the problem, and at first glance, you could be completely enticed by the noise and like, well, look at all this. And as you say, there's a lot of things which just overrides the noise completely, and
It's the essence of science in some ways.
Exactly,
It's
yeah.
working out what you can throw away and still have something that makes sense.
the
And then you
simplest
can build
model,
some
which
solid
explains the
ideas.
most, is the best model, isn't it?
Yeah.
People love building complex models that they can't explain.
But yeah, you're not wrong there. So then, from your PhD, was kind of academia always on the cards then? Like, were you always kind of like, I love this?
Yeah, so it wasn't until I got to doing a PhD that it even came into my head that that was a thing that people could do. I didn't know that was a job.
Well, I was kind of very similar to that. So I did, like, me and you were the same, did undergrad, masters, and then at that point, because I remember doing my undergrad going, PhD, that must be quite hard. I probably won't do one of them. And I did my masters, and then I went, I did my dissertation. I was like, well, a PhD is just kind of like this, but more. So maybe I could do it. And then I managed to get one. And then everyone was like, oh, you can stay in academia. So very similar. I was like, oh, wow. Like, this is actually an option we can go for from it. But as yourself, I didn't know that there was much out there until I got involved in it, which I suppose is quite of a letdown of academia, but we won't get into that anyway.
No, it is true.
No, yeah.
I don't think I knew what a PhD was until third year at university. In my final year, I realised that this university isn't just made up of people teaching me this stuff. There's actually other people doing other
research
stuff
and stuff. Yeah, no,
and then it is that like final year project or something, and you get to do a bit of research, and you're like, hold on, there's people who are actually doing this.
Like, this is what it is.
These aren't just teaching me calculus for the sake of it. That's what you're telling me.
Yeah,
this has more of a point.
There is some application somewhere.
Yeah, no, exactly. It is.
Oh, but yeah. So were you always based in Liverpool?
No, I grew up in Doncaster. I did my degree and PhD in Oxford.
The second Oxbridge professor we've had on, or researcher.
Who's the first?
James Baker, Dr. James Baker.
The mathematician.
So how did you find it down at Oxford? I suppose we have to ask that question.
It was a real mix. It was fascinating. I mean, so this is years ago.
This is years ago.
Yeah, said
40-ish.
Wow.
Not quite. Pretty close.
Wow.
And so it was a very different world then as well.
Yeah.
But it was very dominated by public school. So one of my first experiences was meeting new people, and the first thing they would ask is, what school did you go to? All Cross Comprehensive. Have you heard of it? Why are you asking this? I didn't realise that there was this network of schools where everyone knows, each other, and there's a few that everyone knows about. So that was quite a culture shock. But I soon managed to find some people who I got on with more easily than
the others, than those people. Yeah.
And so there was some aspects of it that I found really tough, because I didn't mix with that kind of society very well. I didn't really want to. On the other hand, it was the first time I felt I could be openly me, because I was really into science, and I was pretty bright. I wanted to talk about these things, and you can't do that in your school. If you start talking geeky stuff, everyone
does football.
I know that too well. Yeah, the amount of times we'd have conversations, everyone go, right, just shut up, lad. We don't want to hear it.
But I loved it from that point of view. You could actually talk with people who were on the same wavelength, who were interested in the same way.
Things,
and there was obviously some very good people around, both teaching and researching.
Yeah.
Just because people were very good doesn't mean they were good teachers. That's a whole other question.
Yeah, that's a whole
some of them were, and some of them were not.
We've had that discussion 1,000 times.
So many times.
How intelligent people do not make good teachers sometimes.
Not
necessarily, yeah.
No, I agree. We had a teacher from Cambridge, and he was awful. One of the most intelligent people I've ever bumped into, but my God, he could
not communicate an idea, could he? Yeah.
He was a lecturer, was not for him, bless him.
Try and get the simplest idea across, and you'd be going.
Yeah, in the end, you'd just be like, I'll just figure it out.
So did you find then, coming from Chris, a comprehensive school in Doncaster, it was, because I think James had the same feelings, it was quite like full of pomp and very much like, as you say, that culture shock of some of these people are from a different world, a different upbringing, and a different.
It was a very strange feeling, that, and a lot of them were very nice people.
Yeah, I'm sure they were.
It's just different.
But just having
it's a shock, isn't it? Of expectations.
So how did you find it moving to Liverpool then, compared to kind of that, like, was there a culture shock, a research difference? Well, obviously there'll be a research difference compared to Oxford, but you understand the gist.
Yeah, so I went in steps, actually. So my first job after my PhD was at what's now the National Oceanography Centre. It used to be called the Proudman Oceanographic Laboratory.
Where's that based?
And so it is now in Liverpool. It used to be over in Bidston on the Wirral.
Right, okay.
So it's Bidston Observatory up on the hill.
Yeah.
And that's a NERC research lab, and world famous for sea level research. So in its specialist field, it was actually a very high level, and exactly the subject that I was really interested in doing, and some of the best people in the world doing it. So it was a different culture, but it was still operating at that really high level, and feeling that I was part of a culture that really cared about it as well, which is what matters most, I think.
I think once you get into an environment where people actually care about what they're talking about, I think that's when you've hit the jackpot, really, no matter what, as long as like everyone's on board. That's what you're aiming for, I think, at the end of the day. But that's what I feel anyway.
Yeah, I think so. That's the thing that destroys the pleasure in a job or an
People
environment,
just
is when
up.
people are, for whatever reason, and there are lots of good reasons why people end up not caring what they're doing. Sometimes it's because the circumstances around them have changed.
Yeah.
But when that shift occurs, then it's just not a pleasant environment to be in.
Yeah, because then it feels like not only you're an uphill battle every day, instead of it just being this enjoyable place talking about the subject. Yeah, everyone is passionate about, but for some reason, like, the light's gone out for some people.
Yeah.
No, I do agree.
Well, it's one of the questions, Chris, that me and Ryan were thinking about when we knew you were coming. You've explained some things about, like, how, as we've just had that conversation then, like, sometimes the noise doesn't matter in a problem. It's getting the model down to the simplest form of it, what elements matter, what factors matter. And over recent decades, we've had a lot of talk about human influence on a warming planet, how much of the humans influence in sea level rise. So we want you to if you could break down, how much of a role does sort of the planet play, and the magnetic fields and all those things, that sort of the properties of the planet affect sea level, and how much of an impact, if it's possible to, like, sort of break down, are we having in changing that, like, sort of foundational changes, like sort of the natural changes that occur?
No, it's a good question, and there are lots of different aspects to that. So the bit that I'm most interested in is these actually quite small differences in sea level to do with ocean currents. The bigger picture is about the total amount of water in the ocean.
Okay.
And by amount, I mean volume.
Yeah.
You can change that two ways. You can change it by physically adding some more water, extra mass, or you can expand the water that's already there. And over, many hundreds of thousands of years, the last million years or so, we've had a sequence of ice ages. The water freezes out, piles up, and these huge ice shelves in the glaciations, and then that can make sea level drop by over 100 meters.
Wow. Yeah.
Wow.
So the last glaciation,
in the last ice age,
sea level was about 120 meters lower than it is now.
That's insane.
I've heard that. I've people talk about the last ice age.
That's horrendously dramatic. Like,
how much more land do we have?
Yeah, that's what I mean. That's insane.
Yeah, and so that's the sort of the planet's own pulse of sea level change, but that happens on timescales of tens of thousands of years.
Yeah.
So coming out of the last ice age, the really extreme period when it was really melting fast and sea level was rising fast, it was going up at about 1 centimetre per year. So that's dramatic sea level rise. And then since then, the last few thousand years, it's been pretty stationary, pretty static. We don't have measurements. There weren't tide gauges 5,000 years ago. Or if there were, we don't know.
They've got lost.
But we can use proxies. We can use places where the tide has made a notch in
In like
the
big
rock
rock
faces,
yeah,
and
yeah.
of where the beaches used to be. You've got sand left
Yeah,
over and things
yeah.
like that. So we can reconstruct it fairly well, and we can see it went up.
There's
to
some
that.
good indicators out there
Yeah.
of, yeah.
So a centimetre a year is huge. That's a metre per century.
Yeah.
Well, that's what we're talking about now. For the human-induced rate of sea level rise, there's potentially a metre in this coming century.
A metre in a century instead of a centimetre.
Well, over 2,000 years, it was pretty well stationary. It wasn't going up at all.
Why was it stationary?
Just
Because the ice stopped melting. So
Yeah,
we've
okay.
come back into...
It had reached a steady state,
Yeah.
basically, the planet.
yeah,
and there was
we've
no-
reached the interglacial, and we're in a reasonably steady state. And then
Yeah.
at some point, we would expect it to dip back into a glaciation,
Yeah.
and the ice would grow again, and the sea level would drop again. But
Yeah.
we've kind of overridden that. Because if you look at these glacial cycles, the CO2 goes up and down with the sea level.
Okay.
How
Because sea level oceans absorb.
yeah, there's lots of feedbacks and
Yeah,
complications going on here. So the simplistic way of thinking is you put more CO2 in the air, that causes a greenhouse effect, that causes heating, that
Yeah.
melts the ice.
Yeah, that makes sense.
But then, depending on how much land is exposed, depending on what the temperature of the water is, some of the CO2 will be dissolved in the water. You can't say that the CO2 caused the rises. It's a feedback where,
Yeah.
it's a natural cycle essentially.
that maybe a bit more CO2 got into the atmosphere, and that caused a bit of a change in the climate system, which then caused some more CO2 to be released, and then the whole system interacts. But they go up and down in step,
Yeah.
Yeah.
really quite closely. And if you look at the CO2 curve, it's gone up and down
It's oscillated.
between a couple of two particular levels
Yeah.
over the last million years.
For like fairly consistently
Yes.
between these two levels.
Yeah. And now, so it goes up and down and up and down and up and down, and it's up and along a plateau, and then we come along and start burning fossil fuels, and it rockets up above that plateau. And we're now so far above that it's almost the same distance as from the bottom to the top.
Shit.
And that's in a spike in the last
But
few
the-
decades rather than over tens of thousands
So
of
not
years.
even like 100 years, just like the last 20, 30, 40 years.
Yeah.
Jesus.
So when we were expecting, as you say, we were expecting it to oscillate back down, or not, whatever you want, word you want to use. I'm not sure if it's a complete a mathematical oscillation, but we're expecting it to drop back down as it's been doing for the last 5,000 years, as you say, and it just hasn't.
Well, we don't know when it would drop. I mean, it would go down sometime, maybe in the next few centuries, maybe in the next few millennia before it starts
It's
falling.
next cycle.
It's a cycle, and it's not a completely regular cycle.
Yeah.
But it would have come back down again
Yeah.
at some point. It's not clear that it will now, because that's all to do with orbital cycles, the Earth's orbit, how the timing of summer matches with the timing of when the Earth's closest to the sun, the tilt of the Earth. All of those things change gradually over the years, and the phasing of these glacial cycles is ultimately glued to that. That's actually quite small changes,
Yeah.
and this big CO2 spike might well be enough to override that.
We don't know.
So it might not go back into an ice age at all. Or if we do, we're talking about many thousands of years probably in the future anyway.
Yeah.
So,
So what's the effect then, Chris? I'm thinking we've got this spike, the oceans obviously rise, and the general temperatures rise, and you got these big ice, what would you call them? Ice sheets in the southern and northern
Yeah, shelves. that could
shelves.
break off and that.
They're obviously going to melt or add more volume to
Yeah.
the. How does that then affect our understanding of the currents that currently exist? Do they change? Does it have any major effect? Do we know how ocean dynamics would change with more volume? Do they change?
well, there's two different aspects here. One is just the sea level rise.
Yeah.
And so the amount of ice that we've got stored in these ice caps now, in Antarctica there's 70 meters worth of sea level. So if you took all the ice from Antarctica and melted it, sea level will rise by about 70 metres.
Jeez, man.
Now,
So
that's
what-
not going to happen in a hurry. It
Yeah.
takes a long time.
So what would that be? So sorry to take you off the train of thought. Relating to the UK, what type of devastation are we talking there? Or is that the whole UK?
Oh, I mean,
under?
70 metres of sea level rise would destroy all the coastal cities around the world. I mean, it's... and most people live by the coast.
Well, of course, yeah.
Everyone in the UK would be living in the Lake District all of a sudden.
Yeah,
in
or
those
in the
hills.
Peak District.
Yeah, in the peaks.
Sorry, yeah.
Yeah.
Very
But it's
dis-
a question of how fast that can happen.
Of course, yeah.
There is worrying signs that what we call the West Antarctic ice sheet, which is not all of Antarctica, it's the chunk on the near the peninsula that stretches out towards South America.
Yes,
Right, yeah,
onto, yeah.
So that looks as if it's on the way out. And that's probably 3 or 4 metres worth of sea level rise.
That's
That
still-
whole peninsula that reaches out towards that south tip of Argentina is on the way out.
Looks like it. I mean, the jury's still out on this, I think, but there are worrying signs that that's the way it's going.
Jesus.
That's a massive, massive.
And again, what's the timescale? 1,000 years? A few hundred years? I really don't know.
Yeah.
Yeah.
But that's a big sea level rise. And similarly with Greenland. Greenland has about 7 metres worth of ice on it. And Greenland has been really steadily accelerating
Becoming
the rate
green
that it's
again.
melting.
Yeah.
Yeah.
So we're now at sea level rise of about 4 millimetres per year from a background of less than 1 millimetre per year.
Like, I know it sounds...
So yeah, it's small,
Small.
amounts, but when
Well,
you add
that's
them up
quite-
over
that's-
a decade, a
So
century,
4 millimetres a year?
yeah.
Jesus. That's insane.
So
Like, what worries me the most, though, is that, like, these signs are so obvious and yet nothing happens. I mean, yeah, obviously there's the geopolitical kind of arguments why it doesn't happen or whatever, but surely at some point that's got to take a sidestep when it's so obvious.
well,
Well, I suppose that's a conversation for a different day, but yeah.
it's the boiling frog issue, isn't it?
Yeah.
It's if you heat the water up slowly enough, the frog will stay there and not hop out. And
Yeah.
But it's still going to
are we cleverer than frogs? I really don't know.
Yeah.
I think some of us individually might be, but collectively is a whole other
Yeah,
question.
maybe not.
Yeah, the frog will still meet its doom, even if it boils really, really slow. Yeah. It will
Well,
still die.
I like it. So I suppose then for yourself, Chris, one of the final questions for us is, what are you researching sort of now at the minute, and then what's coming up for you? What you're aiming to achieve end of 23, coming into 24,
What are you
25?
involved in?
Yeah.
What exactly
so I
research you do?
just got a proposal funded to look at something that
Congratulations.
I've been working towards for a very long time, and it's only just sort of coming together, which is looking at the boundaries of the ocean. So when we look at sea level, people always think in terms of global sea level.
Yeah.
No one actually cares.
Yeah.
No one actually cares about what the global mean sea level is. No one's feet ever got wet because of global mean sea level. It's
Yeah.
local, present day sea level that matters. It's what's
Yeah.
happening here and now, and that's at the edges. It's where the ocean laps up on the land. So there's a lot of interest in trying to work out what the difference is between these coastal sea levels and the middle of the ocean. And it's through thinking about that that I've come to realise that the processes on what I call the boundaries of the ocean, which is not just the coast but the continental slope,
Yeah.
are really important in determining how the whole ocean works. So this is from looking at some theoretical ideas that I've done over the years, but also looking in an ocean model. So these days we have computer models of the ocean, which are really quite good. They can, just from fundamental principles, get the ocean circulation pretty well right. You get the Gulf Stream is about the right size in the right place.
Yeah.
You get the right amount of variability. It's like a weather model, an atmospheric model,
Yeah.
but for the ocean. And in the ocean, everything, all the storms and things are on smaller length scales. So there's a lot going on. Whatever we look at in these models, and in the observations that we can take, which are mostly at the surface from satellites or a few places in the interior, we see that what happens in one place is not related to what happens in another place. If you see whether the sea level's going up and down here, and then look somewhere else, it's going up and down almost independently, because there's so much dynamics, so much sloshing around of the ocean.
Yeah.
But the equivalent of sea level, once you're under the water, is the pressure. When you watch the weather, they show you, sometimes when they're feeling good and scientific,
The pressure,
they'll show you the isobars, the pressure map.
Yeah.
And the wind blows around the isobars. It's exactly the same thing. It doesn't blow from high to low pressure. It blows along the isobars. So when you're below the surface, you want to know about the isobars in the ocean. And that's the pressure on the boundaries and in the middle.
Mm-hmm.
So exactly the same issue happens when we look at those. Nothing's related to anything else. There's lots of eddies and wiggling around and turbulence and mess.
Yeah.
But if you look at the boundaries on these, especially on the steep continental slopes, you find that they are correlated over thousands of kilometres. There's something about the interaction between the dynamics in that steep slope that stops the turbulence from dominating. It stops the eddies from being the big factor. So when we look at just at the boundary, for example, in the eastern side of the Atlantic, so all the way from Scotland down to the tip of South Africa, in the model, if I look at the pressure at Scotland at, 1,000 metres depth, and the pressure on South Africa at 1,000 metres depth, they can be really well correlated. And we see these signals propagating from the equator all the way to either end. So this pressure on the boundaries is a measure of not just the local wiggling around, but the whole system.
That's amazing.
And that ties in with what I was talking about before, this overturning circulation.
Yeah.
Because it turns out the way we want to monitor the overturning circulation is just the pressure difference between the east and west of the ocean. So again, we want to know the total flow northwards. If the flow is northwards, there's going to be a slope from east to west, or a pressure difference from east to west.
Yeah.
So if you can measure the pressure difference between 1,000 metres on the eastern boundary and 1,000 metres on the western boundary, you've measured the total flow to the north in the ocean.
Wow.
And what this means is the whole ocean's connected.
Yeah.
I can see things that if something happens in the Atlantic, it influences what happens in the Pacific.
Yeah.
There's actually a sort of somewhere around 40 centimetre sea level difference on average between the Atlantic and the Pacific.
That's huge.
40 metre?
40 centimetres.
Centimetre.
That's huge, isn't it, when you think about it?
When you think about the amount of water
Yeah,
that means.
that's what I mean,
Yeah.
That's amazing.
It's weird how it's all, as you say, interconnected.
That's what I mean.
Don't think about it like that,
but
do
like-
you? Being like completely reliant on
But what's mad
on
is
each
like,
other.
I kind of did, because like I just kind of always thought of the ocean as
One.
the water as one thing, but then it's interconnected in not the way I thought it was. It's
Yeah,
like so
yeah.
much more meaningful, which I mean seems kind of obvious when I think about it now, but that's insane.
So your research will be focusing on actually, rather than looking at mean sea level, which you say is actually quite meaningless when you're trying to look into things, it's actually the boundary influences, and
Yeah. So the mean sea level itself, that's important too.
it's important. Yeah.
I mean, it's very important from the point of view of understanding climate, and it's a great integrator of what's happening in the whole system. But just as important is the difference in sea
The
level between
granularity.
one place and another, and especially when you're looking at the
And
boundaries.
what will the research be focusing on? A specific area, or
So what I'm trying to do is work out how it's just a little piece of science. I'm trying to work out how the whole ocean works.
that's what I'm saying.
I'm trying to do this connection between
Yeah.
all
Just
the
the
ocean
whole thing.
basins, and
Yeah.
because we know that this pressure is correlated over very large scales, what it means is there's communication, meaningful
on.
communication. But there are differences. The sea level is different between one basin and another.
Yeah.
These pressure signals, there are jumps. The pressure will suddenly change from one place to another. What causes that? Where's the cause and effect that sets up these patterns?
But still keeps them related in some way.
Yes.
That's sick.
And but the nice thing about it is because there are so few things to look at, because there's just a few patterns, this large-scale thing that's going on, it's plausible. It's feasible to actually
it's a feasible
dig through it and understand what's going on.
And try to ascertain an answer rather than it just coming out of it again with a theoretical kind of idea.
Has this work started then, Chris? Or?
Just started over the last month. Yeah.
Wow. Okay.
So how long you got the project for on that?
It's a 3-year project.
Brilliant.
Yeah.
Good luck with it.
Well, I look forward to hearing the results because that's very interesting.
Yeah. Well, we'll put the info in the.
Yeah. So if you send us a few links or whatever, we can put it in the descriptions. And we can send people over to look over at the work. Yeah. So thank you, Chris, for coming on, giving us your time.
Oh, thanks for inviting me.
It's been so interesting, and then it's expanded my knowledge anyway, or even just the way of thinking of things. Definitely.
I think this one, the ocean for me is paleomagnetism was a minefield, but I felt like I had more grasp of paleomagnetism. I don't know why. Why have I got more grasp of that?
It's one of the things, isn't it, with the ocean? It's
abstract to me.
Yeah, because it sounds weird. I don't think about it in that way.
It feels like the most abstract concept. It's the ocean. I've swam in it a million. It's obviously very real to me compared to a magnetic field. For some reason, the magnetic field, I had understanding of it.
Yeah.
The ocean's very abstract to me. I don't know. Even like the simple conversation of sea level's higher here and lower here, and it's very like, I don't know if you found this, as you said when you were getting into it, Chris. It just feels abstract.
Yeah, it really does.
Yeah.
You want one more step of abstract?
Go on, let's hear it.
So, it's higher in some places than other places. But what do you mean by higher? That's to do with gravity.
Yeah.
Have you actually had to climb in order to get from one place to another? So what if the sea level wasn't higher in one place than another? What shape would it be? If it was just completely level?
Yeah.
Turns out the answer is complicated, bumpy, wobbly thing. We call it the geoid. And it's the shape of a level surface. Every little bump on the sea floor, every mountain, has a gravitational attraction towards it that pulls the water towards it, makes a little pimple of sea level.
Yeah.
So when I say higher or lower, I mean compared to that
base level
bumpy, wobbly surface, which is it's 100 meters higher in some places and 100 meters lower in some places. Except it's not, because that's the definition of higher and lower. If you drew a sort of nice smooth ellipsoid and compared it to that ellipsoid, then it would be above the ellipsoid in some places, below it in others.
Wow.
But it's not above. Now, those two places that are above the ellipsoid and below the ellipsoid are at the same level. One is not higher than the other.
That's insane.
That's abstract. This is.
That's blown my mind, blown my tiny little mind.
Even something as simple as the salt analogy, and like, it's not an analogy, it's real, but like,
it's just so complicated.
That's confusing.
Do you want to see what I think it is as well?
How does pouring a bucket of salt into a bucket of water not mean that there's now a massive it's such a weird
so interesting
thing.
Well. But like, what I find as well is, like you were saying about space, we get taught space very.
You're right.
You don't really get taught about you do in that.
Yeah.
You're right, you learn physics, you learn a bit about magnetic poles, you're right.
Like the most you learn about the oceans is trying to figure out what the names of where they are.
That's true, that's actually a weird thing for the education system. There is no understanding of the ocean.
Dynamics of the ocean.
At all, through any, like even physics, when you do physics and science and stuff. I don't remember learning about the ocean.
Yeah, I actually found it really difficult when I was choosing universities to find physics degrees that covered things about planets.
The ocean?
Never mind the ocean, just anything on a planetary scale.
Planetary scales,
everything was about relativity, quantum mechanics.
You're completely right,
physics.
Of course. That is why I did understand paleomagnetism.
That's what I mean, because it's more, even though
that is planetary, but
even though it's not familiar, it's more familiar.
Yeah, you're right.
The oceans, like these crazy dynamics that go on, are in a way so foreign.
How could something so integral to life that everyone's experience not be mentioned at all through the curriculum until you actually choose it at university?
It's weird, isn't it?
That is weird, isn't it?
I always say when we're trying to persuade students to apply to do oceanography, and there are a lot of people thinking about doing geography. Well, if you're doing geography, why don't do the other 2/3 of the planet too?
Oh my god! Of course, it's not meant. Oh my god! When you do geography, maybe I'm looking back with bad glasses here, I don't remember mentioning the ocean from geography
Well,
teacher.
you wouldn't, would you really?
It was just all about mountains
Or like-
or rivers. You got a lot about rivers.
Well, of course, it's on land. Or maybe
Yeah,
you got
it's
some
on
stuff,
land, yeah.
Or maybe you got stuff about tectonic plates and tsunamis, maybe. But
Which
that
is
was
important, but you don't get any like actual ocean dynamic stuff at all.
That's insane. Yeah, education. If you're watching this, the Minister for Education.
Change this up.
Yeah, he's not going to be watching this. Or is it she? And that was very sexist of me. I do apologise.
I wonder how many though. I wonder how much more young people would be
Interested in it.
interested in the ocean if there was just a little tiny insemination of thought about it at some point in the
'Cause I suppose
in
as well-
secondary school. Like you get about the magnetic fields, like you get about these other simple things, not simple things, but you get the little 2 lessons on it in science about magnetism. You don't get that with the ocean. Maybe
no.
you do these days. I don't know, but
Yeah, I think part of it is just that fluid dynamics is hard.
Yeah, it's
So,
very
yeah.
complicated, to be
Avoided.
fair.
as I've
But-
found out right now.
But there are things that you can do the phenomena. You can say where the currents are, and then you
Yeah.
can say, and there are some very weird reasons why they do this.
Yeah.
But that would pique people's
That would
interest.
pique people's interest,
Well,
of
as you
course.
say, because like you actually you could try and teach about fluid dynamics. Like physics is taught in GCSE, where they say there's 7 fundamental forces. Well, that's not true. Like you've got, what is it, seismic? This is what they say in school. Isn't it? It's, what is it, seismic? It's just fucking, there's all weird stuff.
I haven't got a good
Anyway, I
memory
can't
of that.
remember what they say. But then there's only 4 forces, isn't there?
Yeah.
Yeah,
But they say there's 7 in secondary school.
it's insane.
To make it simpler, is that?
Yeah, so basically, seismic activity, there's a force.
Oh, okay.
So
Are
you
they?
could teach the complicated thing without teaching the fluid dynamic complicated thing. Anyway, that was very off piece to end. Thank
poignant
you.
point,
It
though.
is poignant. Oh yeah, better education is what's needed all around. Thank you very much, everyone, for watching and giving us your time. But before we end, Chris, we'd like to finish on two more questions that are very not about what we've talked about. Or it might be what
Are
we've
these
talked
going to be
about.
as hard as the Marmite one?
It's up there.
Maybe one of them.
So the penultimate question we'd like to ask you before we let you go is Sam's famous question. Take it away, Sam.
Right, Chris. You're on your deathbed, and I'm the great provider. I come down and I say, Chris, before you die, what is the one thing you want to know that you currently do not know that will make that good night all a little bit sweeter? It could be something to do with the research you do. It could be something more personal. What is the one thing that you currently do not know and you're thinking, I need to know that?
Okay, this is completely off the
Say it,
trail, but
yeah.
what is it that makes people cooperate rather than fight?
Wow. Okay.
That's brilliant, that.
Because we've had answers like, what is the meaning of all this? But
Or like
what is
why-
it that makes people get on
Cooperate.
and want to... Yeah?
Yeah, like, is it the sheer selflessness? Is there more to it?
Is it the pursuit of you need
what's
other
the thing you
people?
have to tweak to shift between those two things?
Between sheer violence and cooperation.
Yeah.
Wow.
That's insane.
I haven't got an answer. That's why
No,
we
neither.
want to know.
No, but like, I've thought about that question, but never like that question, if that makes sense. Like, you know,
What is
like
the
more
tipping point
generally,
to
like,
anarchy?
yeah, like obviously we think more generally about why the things happen, but yeah, why do we cooperate?
You think about society in general. What is the tipping point where people go from actually working together and the greater good to complete chaos? And you see it happen in places, don't you? Where it goes from it works to it doesn't work, and now it's anarchy. Wow.
Love it.
I love,
Good
yeah, that's
question.
a great answer. Normally people, especially scientists, they go into their own field and try what's a question they don't know.
Yeah.
But I like that.
We've had a few like philosophical or psychological ones, and I find them dead interesting.
Molly's was the best, a PhD student who said she wants to know what happens when you die before she dies. And I went, what if the answer is nothing and you're about to die? And she went, I want to change my answer. I want to change my question.
I was like, you know what? At that point, I'd rather it be a bit ambiguous. Yeah, right. So there's nothing, mate. It's just pure black, and you're like, oh no, it's coming in an hour.
30 minutes I've got.
Just proper crying. So the last question before we let you go. So we kind of ask the main question, then follow up with a kind of one underneath in case it's a bit difficult, because it's a lot to think about. What's your favourite song of all time? Or if you can't think of that, like, what's one that's really sticking with you at the minute? This will be the hardest question we've asked you all day.
See, favourites are dangerous. They change all the time.
Yeah.
But I was a massive Queen fan as a teenager.
Yeah.
And still love the songs and the live performances were amazing.
Yeah.
So I'm going to go with Somebody to Love.
What a song. Yeah, because what we do is we have like a playlist on Spotify, so we add everyone's song. So all the guests we've had on, we ask them a song and then we throw it in. So we'll have a massive playlist that everyone can just go and listen to. So we'll add it on.
Somebody.
It's such a good song.
Yeah.
But yeah, so thank you very much for your time, Chris. Thank you for coming on.
Thank you,
It's been
Chris.
so interesting. Thank you everyone for watching. If you liked it, make sure you hit the like button. If you disliked it, hit the dislike button. We don't like you, but thank you for watching anyway. Keep watching. Comment, let us know your thoughts on the ocean and what you learned about today. Has it made you think a bit more about the other 2/3 of the planet that we
That we
can't-
don't. That is not taught in
Yeah,
school.
that is not taught in school. But until then, we'll see you in the next one.
Peace
See you
out,
later.
people. Bye bye.